In this video, we're going to talk about the possibilities of logarithms. Is it possible to do the logarithm of anything? Turns out, no. Think about this. What is log base 2 of 0? Well, that means 2 to what power is 0? Well, would that be 0? Like 2 to the 0 power? No, that's 1. So what power could possibly give us 0? There is no power, right? This is an impossible logarithm to do. It's impossible. Even if the base was different, it would still be impossible. So if I had log 0, so it's implied that the base is 10. It's implied that this is the common logarithm. This would still be impossible because 10 to what power is 0? No power. There's no power that would work here. So yeah, this is an impossible logarithm. Also, think about this. Log base 2 of -8. Well, that would be 2 to what power is -8? Maybe that's like -3, 2 to the -3rd power. Does that get me -8? It doesn't, because a negative in the exponent doesn't produce a negative answer, right? A negative in the exponent means you have to do 1 over your answer. So you get 1 over 8. You don't get -8. How can you get -8? How do you get a negative answer at all? What power do you have to use? There is no power, right? So this is also an impossible logarithm. Changing the base, once again, does nothing. It doesn't solve this issue. It doesn't make the problem all of a sudden possible to do, because now I just have to think about 10 to what power equals -8, but still that's not possible. You can't raise 10 to a power and get a negative number. It's just not possible. So this is an impossible logarithm as well. So what should your main takeaway be here? The logarithm of 0 is impossible, and the logarithm of negative numbers is also impossible, at least considering only real numbers as our possible outputs. Now, remember the idea of domain, right? Remember domain. Domain is all of the numbers that you are basically allowed to plug into your function, right? All of the numbers. So if I have a function like f of x equals log x, what are all the numbers I'm allowed to plug into this function? Well, I can't plug in negative numbers. I can't plug in 0. So I guess I'm only allowed to plug in real numbers that are greater than 0. In other words, positive real numbers. So this would be my domain. My domain is real numbers greater than 0 or positive real numbers. Even if the function was more complicated, you could still do this. It's the same exact idea. You just maybe have to know some algebra. So even if I had something like this, same exact idea. What's the domain here? Well, it's going to be whenever the argument is greater than 0, right? My argument has to be greater than 0. Those are the only kinds of logarithms I can do, right? So, all right, when is the argument greater than 0? And then I just solve for x here in this inequality, and I end up with -5 over 2, -5 halves. So this right here is my domain. So all real numbers greater than -5 over 2, that's my domain. And you can check this, literally plug in, like if you plug in -5 over 2 here, you'll see that you get the log of 0, which, as we said, is not possible. So that's why -5 over 2 is not part of the domain. No, the domain is everything larger than -5/2. So plug in numbers that are larger than -5/2, and you'll see that now we're doing the log of positive numbers. Yeah, these are logarithms that we can actually do. So yeah, so this actually makes sense if you plug in the numbers. All right, thanks for watching.